has requested that we cover Mass Spec, so let's get to it.
We are actually going to do Mass Spec now, and I'm going to give you something that I like to call a Mass Spec cheat sheet, so it's everything you need to know about Mass Spec on one page. First thing we need to go over is, what is Mass Spec? So Mass Spec is a type of spectroscopy where you take a molecule and you hit it with high energy beams and you break it apart. Once you get these broken apart fragments, you are going to be able to find the mass of your molecule. So this tells us mass, aka molecular weight, and that will help us determine a formula. And as I said, we use high energy beams to break the molecule into radicals. The four main aspects of Mass Spec, the four things we're going to focus on, are the base peak, the M+ peak, M+1, and M+2. The base peak, as it's stated here, is the tallest peak, and therefore it is the one with the highest intensity, aka the highest abundance. The M+ peak is going to be our parent peak. That is our unfragmented radical, aka our total mass of the molecule. The M+1 peak is going to tell us about our isotopes of carbon, hydrogen, and nitrogen. 99% of the time, you are always going to see a tiny M+1 peak following the M+ peak, and that is because we have a 1% abundance of carbon-13. The reason we call it the M+1 peak is literally we have the peak at M+, which is your total mass, and then one mass unit over will be this M+1 peak. M+2 is same thing, it'll be 2 units over. The M+2 peak is going to tell us about the isotopes of oxygen, sulfur, bromine, and chlorine. All right, these are things that you have to actually remember the percentages for. Oxygen is not the most important, it is just less than 1%. So it's super tiny. Sulfur is going to be 4.4%. Bromine is where it gets interesting. It's 98%, and that is a 1-to-1 ratio. And chlorine is going to be 33%, and that is going to be a 3-to-1 ratio. Now I'm going to explain what those ratios mean. So if we have our M+ peak, let's say, we have our little tiny M+1, and then we're going to have multiple possibilities for our M+2. So I'm going to go ahead and duplicate that so I can show you what I mean. So bromine, if we have a bromine present, the M+2 peak is going to be approximately the same height as the M+ peak. Similarly, the chlorine, if we have a chlorine present, it's going to be approximately 1/3 of the M+ peak. So this is, when I say 3-to-1, I mean M+ compared to M+2. That's pretty much it. Remember these. The two most important ones are bromine and chlorine. One thing I do want to tell you about bromine, though, which can be a little tiny bit confusing, is that for bromine, since it's 1-to-1, what that essentially tells us is that on Earth, we essentially have equal abundance of the two isotopes of bromine, and that's why on the periodic table, the mass is 80. However, in reality, since we have this 1-to-1 ratio, we know that it's 50% a mass of 79 and 50% a mass of 81. So you just have to know conceptually that we have 79 and 81 as our masses, not 80. And that can further be understood because we can think of it as 79, right? And then 1 mass unit, 2 mass units, 81. Yes, I'll leave that for a moment. I almost forgot you guys weren't live, and I was like, I'll let you digest that for a second. But yes, the next thing you have to know is nitrogen is really interesting. So nitrogen is represented by the M+1 peak. However, that's not what you want to look at when thinking about nitrogen. I know it's really weird. So when we look at our M+ peak, aka the total mass, if you have an odd number for your M+, aka your total mass, that means that your compound has an odd number of nitrogens. So odd M+, wow, that was really weird, is an odd number of nitrogens. Please remember that. We will do an example, but I want you to remember it that way. Okay, so next thing I want to mention about Mass Spec is H2O or OH. This is a little bit complicated if you don't see an example, so after I explain it, I am going to do an example. So OH can be lost as either a hydroxyl radical or an H2O, which is water. If it leaves as the hydroxyl radical, it will leave as OH, and that would mean the mass of that would be 17. If it leaves as water, it leaves as H2O, so that would be minus 18.